Hello friends, welcome to MultiSims. Today we will continue with the MultiSim, that is the simulation part of MultiSim. Before that, let me review about our last video. In the last video we have seen about the basics of MultiSim, that is why you use MultiSim, what are the advantages of using a virtual component, that is they can be easily changed. The values of the resistors, capacitors or the components can be easily changed according to our requirement, but in case of hardware we need perfect accuracy. So these are very easy for simulation and hence can be applied on hardware circuits very prominently. So here we have taught you about the real comparisons between the real and the virtual components. Then we have discussed about the steps to install MultiSim. There were various steps. A PDF file, a Word document is also attached to this along with the video. We have seen various parts of MultiSim, that is the opening screen. There are toolbars over here, you can see toolbars, design toolbars, the workspace or the circuit window. Then we have gone in brief about the view toolbar, standard toolbar, components toolbar, how these toolbars can be used, where to use, where is the run simulation, stop simulation, how to use this right hand side toolbar, that is oscilloscope, multimeter, wattmeter. Then we have also read about placing the components on the workspace, that is we have to right click on the workspace, that is the circuit window, and then we have to choose place component. This window appears, select a component. From this we have to select one or more components according to our requirement or our design, then we place them into our circuit board. Now today the main topic is about the simulation part in case of MultiSim. In the previous video we have learned almost 75%, and with that, assuming that we are clear about the basics, now we can easily come to the simulation part. The more you learn, the more you use it, the more you will explore. This is the motto what I am saying you from the first time. In this case, suppose we will use a battery, a simple circuit. We have to arrange these components. A battery of 12 volt, there is a switch, there is an indicator, a bulb is used in this case, and finally it is grounded to this. Now here we will use a resistance of 1K. We will practically see the demo regarding this. So for that we need the basic concepts of wiring. How to begin our wiring? We have to move the cursor over the terminal. Notice that the cursor changes its shape in this type. Whenever the cursor shows like this, that means the beginning of the ground symbol starts. The cursor shape changes, showing that a wire is beginning on the ground symbol. Now after selecting all the components, you have to wire it perfectly, selecting all the negative to negative terminals and the positive to the positive respective terminals. For this you need a better view of digital analysis, or you can say the more you are prominent with analysis of digital circuits, combining them, wiring them, then this simulation will be very easy for you. Once you click, now you can start the wire. To end the wire, click on the another terminal. Continue the wiring circuit until you have the complete circuit. You need to complete the circuit. In this case you can see the whole circuit has been completed using a switch, a voltage source, finally to the ground, and an indicator. Now after this we have to run this. After this we have to run this simulation and we will see how it works. And this will be shown by a demo. Now you can see I have used AC source across this voltage, across this lamp, and a sonar alert, so that you can hear a beep sound. Now when I run this, you can see you can hear this. Now I have connected an oscilloscope across these two terminals, that is the positive and negative terminal. We can also see what is the voltage rating across this flowing through the circuit. Here you can see an AC source, that is a sinusoidal voltage. You can observe over this oscilloscope. This works exactly as we work in the laboratories, you can change the magnitude. It can be smaller according to your requirement. You can change the time period also. So these are some operations regarding oscilloscope simulating the circuits. Now before simulating all the circuits, you have to make a design of what you want to do. That is, you are given with a particular circuit, you need the components, and the accuracy of the components can be changed easily through this multisim. That is, we can use various values of this virtual components, and it makes it very effective and very flexible on our part to work before on a hardware circuit. Now I will stop this simulation. From the right hand side, I can use this multimeter also. This is a multimeter. I connect the positive terminal to this positive node and this negative terminal to the ground. Now again I run the simulation. Here you can see the sinusoidal voltage, and this is the beeping sound across this indicator, that is a buzzer I have used. Now on the part of multimeter, you can observe what is the current rating, what is the voltage rating. Now see, this is the most practical thing I want to show you. After using for a long time, this is a 120 volt RMS value of 60 Hz AC source was used against a 12 volt lamp. After using for so many times, the bulbs get fused. You can see there is no more beeping sound, that is, the circuit has been broken over here on this bulb part. Now no current flows through this circuit, and hence this bulb is fused. You can replace this bulb. Click on the bulb, you will get a blue color box. Right click, stop the simulation, click on the box, click on the bulb, you will get a blue color box. Replace component. This time I use a lamp of 100 volt 100 watt. Let's see what happens. Yes, it glows. I hope this bulb lasts for some time so that we can see this. You can see here, these are very practical things in our daily life. This is the multimeter. As we use a multimeter, putting the positive and negative terminals across 2 points, and we observe the net voltage. Here the voltage reading you can see on the screen. So here I have made a circuit for you. In this circuit I have used an IC called 555 timer IC. You will study about this 555 IC in higher semesters. Here MultiSim provides us with lots of ICs, like analog ICs, like analog and digital ICs like NAND gate, NOR gate, microcontroller units, CMOS, TTLs, BJTs, diodes, resistors. So this is one of the ICs. I want to show the application of this IC. For the time being, just remember 555 is a timer IC. It will switch on and switch off according to the time given. Here you see 12 volt supply is given to this 555 IC, and R1, that is 1 kilo ohm, and R2 10 kilo ohm are attached to this. The configuration of R1, R2 along with these two capacitors make the timer. You will study about this in the further. So for the time being, just use it, design the circuit, and I will show you how it works. Now I run the simulation. You can see the bulb glows. It is yellow in color. The time depends upon the resistance values, this R1, R2 and this capacitor. Now you can see the bulb doesn't glow, and again it glows. So there are two times, that is the on time and off time, and it can be easily visualized through this oscilloscope. You can see how this time differs, the oscilloscope is running, and again when this oscilloscope line comes to this ground level, it is switched off. Now you can see it is switched on, the bulb is yellow in color. Suddenly bulb goes off, that means this shows the off state. So this 555 IC is used to show the on and off state simultaneously, and these circuits are very readily used in our laboratories, various experiments. So before designing a circuit, you must know the characteristics of the IC, the indicators you should use, the resistance components and the capacitors, the exact value of them should be used in this case. So this was all about simulation across MultiSim. Hope you like it. The more you practice, the more you will explore. Thank you.